Okay, and problem number 4, a ball is dropped from the top of a 50-meter high cliff. At the same time, a carefully aimed stone is thrown straight up from the bottom of the cliff with a speed of 24 meters per second. The stone and the ball collide partway up. How far above the base of the cliff does this happen? Okay, so I think what I'm going to do is we'll look at these two distances here. The ball's going to travel this distance. I think I'll call that maybe y, delta y of the ball. And the stone is going to cover this distance. I'll call that delta y of the stone. Obviously, these two, y ball plus y stone, have to be equal to that 50 meters. So let's see, there's going to be constant acceleration motion for both of these. So the ball is being dropped, so it's going to be, put parentheses around this. So this first term is going to correspond to the ball here. It's going to be VIT, so it's going to be 0 times t plus 1/2 of 10 times t squared. And let's see, this one here is going to be 24 times t plus 1/2 of negative 10 times t squared equals 50 meters. The reason why I have a positive 10 here and a negative 10 here, I'm really looking at the distance that it travels. This thing's going to be speeding up, and so I'm just looking at this distance being equal to a positive amount. Here the thing is slowing down, so either this one here is going to be negative or this one's going to be negative. And since it's moving upward, I think I want my overall term to be positive there. It's not going to be going downward. So that's why I've got it set up the way I have. So combining these things together, I end up getting 24t plus, let's see, I've got 1/2 10t squared minus 1/2 10t squared. So that's going to be plus 0, I guess, really, right? 1/2 of 10 times t squared plus 1/2 of negative 10 times t squared. That term's going to drop out. It's 0. So I have 24t is equal to 50. So that means my time is equal to 50 meters over 24 meters per second. And so my time is 2.08 seconds. It wants to know how far above the ground it is. So I could plug it into either this equation here to figure out how far the ball moves and then subtract that from 50, or I can plug it into that one. It doesn't really matter. I think I'm going to plug into this one. It looks so much easier. So it's going to be 50 meters. Because, right, I mean, it's 50 meters right now above. And so I'm going to find this amount right here and subtract it from 50. So minus 1/2 of 10, which is 5 meters per second squared, times t squared, where t is 2.08 meters, or seconds, excuse me, seconds squared. And this is going to be equal to the distance, really it's the distance that the stone ends up going. So the stone, I guess. And so this is going to be 50 minus 5 minus squared. And I get an answer of 28.3.